Well, we have another beer social tonight, so we have something. We have something to live for. Hoo-hoo! Yay! Stop that. If root beer, yeah, right. Okay. I tell you what, though, isn't it great to come to a conference and see young people? I mean, students and whatever, because that is literally the future. But I love to be involved with something that even youngsters can get involved and use their creativity. And he was, what was your name? What's your name? Kevin. Kevin was in a birds of a feather session with us a while ago, and he embarrassed most of the adults with his question because it was just spot on. It's kind of like, get the kid out of here, you know. Anyway, we're glad y'all are here. Housekeeping. Let's see. Everybody's got the internet, the inner Google, as my wife calls it. We're having another giveaway tonight. Another Android tablet. And right now we have our speaker, Jesse Andrews. He is a longtime open source developer and supporter and enthusiast and advocate, and is now with Rackspace. And y'all are cooking. Rackspace is blowing and going. And come on, tell us what we need to learn. He's from Kentucky originally, so if he talks funny, everybody make fun of him. Okay.
Cool. Thanks. So yeah, I'm currently at Rackspace, and as he said, I've been doing open source for a long time. While I was in grad school, I was studying theoretical computation and algorithms and complexity theory and all that fun stuff, and I just wanted to keep my hacker skills honed, so just started doing open source. And there's a game on Linux called Tux Typing, and did that when I was first getting started in grad school, and just continued working on things like Flock and Mozilla and Grease Monkey and all sorts of fun things like that. But this cloud thing happened, and all of a sudden moved from just caring about what's happening on one server to what's happening on lots of servers. And when people start talking about cloud, they mean everything. It's just the new term for internet, inner Google, the inner cloud. So I'm not talking about things like Google Apps. I'm not talking about things like these cool hard drives where you plug in the USB thing and all of a sudden your data is accessible from anywhere. Those certainly are cloud and are part of the internet cloud thing. There's basically the concepts of being able to decouple the act of getting things and then like procurement and the actual allocation of things. And so what that means is, with hardware, getting a server, going to Fry's or going to Dell or HP and buying a server, and then actually allocating it for use, and being able to change that allocation dynamically via APIs. And it really just speeds up everything. And so a lot of what we're talking about is just in cloud is how we apply those concepts of automation and API driven to everything else. And so we're going to be talking about infrastructure as a service, because that's where we just figured out that there's actually a need to spend more time at that layer. And so how do we build a cloud on racks of standard hardware? So story, in the beginning, a long time ago, a few years ago actually, I was at NASA, and we went there to help with the open data, open transparency, and open government movement. And because NASA's really neat because they have a lot of computation, they have some of the fastest supercomputers in the world, and they also have a lot of data, both cool things like the Mars rover, but also they have more satellites, like at least of the non-rogue agencies, pointing down at us, at the Earth, working on climate data and things like that. And so, when the oil rig exploded, within hours there were satellites capturing data, and there was lots of massive computation jobs spun up in order to start calculating what was happening on demand. And so NASA had that need for dynamic bursting amount of computation. But we realized that if we wanted to use the cloud, use that sort of build those higher level concepts for the scientists and researchers, we had to build it, because just the sheer amount of data that we needed wasn't possible to really transport it all to third-party providers. So if we went with proprietary solutions, we would be right back where we started, where we were locked into vendor solutions. And we've seen this before, and we've also seen a good answer to it. It's that we need an open platform. So we were at NASA working on both. The goal of it was providing a platform layer, and some of that could be a conventional, like Heroku-like, Google App Engine-like web applications, but also scientific computation. And so we were working on combining all these open source technologies, and we were there as open source contractors, helping the government with open source and open data and so on and so forth. And we tried to take existing infrastructure as a service open source projects and just apply it. And we realized through the act of trying to take some of these open source projects that we needed a better solid foundation. And so that's when we created Nova. Nova was a Python application to be a cloud. And the cloud will have an open source operating system. What's really neat is there was this company called Rackspace that realized that they needed an open source operating system at the same time too. They're one of the larger cloud providers, but competing on a closed platform was an arms race. And they have as many servers running they have tens of thousands of servers running Linux. And when you count virtual machines, they have hundreds of thousands to millions of Linux servers that they support. And they realized that we needed something more like a Linux or Apache for the cloud rather than them to even own their own proprietary operating system. So they decided that they're going to stop what they're doing with having their own proprietary cloud and open source everything. And so they saw what we had done and open sourced as Nova and decided to create OpenStack based upon a combination of what we had done and what they had done. And so the goal was to produce a ubiquitous operating system, open source, that's works for both public and private and scales from the needs of somebody who has a private organization all the way up to service providers. So the founding principles is we didn't want open core. We wanted it all to be 100% open. And we chose the Apache license for reasons of it requires things like when you commit code, you're giving, if you have software patents, you have to say that you will not use them. You're contributing irrevocable license to that patent. And we wanted to do, actually, we called them like the four opens, like open source, and open design was really important because you see a lot of other projects where like they will do open source, but it's done such that they basically throw code over the wall every few months. And so there's other cloud products that are done that way, where the teams don't really let the rest of the community contribute to it. And so it was really important to us that we created a solution that worked for private enterprises and organizations and public sector as well. So everything is open. Even like if you want to make changes to our website, it goes through the same open review process, and you could go make changes to the HTML and submit them, and that goes there too. And we have weekly meetings in IRC with our policy board and so on and so forth. So it's all open. Our cloud is all open source and built on top of other open source software. The primary language is Python. The reason being is that if you think about what a cloud really is, it's gluing together lots of components. And Python is a really good language for a mix of those sort of low-level integration with the operating system and high-level ability to connect lots of different applications and glue them together. So enough about talking what it is. I'll just give a quick look at what, from a user perspective, how long has that been there? Okay, sorry about that. Yes, I'm supposed to be in a meeting right now, so I'm glad I'm here. So one of the things that exists is a Django-based dashboard. Many companies, when they go and deploy a cloud or deploy any technology into their company, will want to integrate it into their own sort of portals and systems and whatnot. But we realized early on that if we don't have an example one of here's, and by example, I mean it needs to be fully fleshed, it needs to be workable, but but the goal is that it's completely powered by APIs so that you could replace it with your own internal cloud as well, your own internal dashboard as well. So you could log in, see your resources, create them, and then even if you wanted to do something like, like you have to test out how your application works on Windows, you could launch a VM running Windows and then use another open source project called NoVNC that uses WebSockets and Canvas and other things to actually render a VNC console in your browser. So you could start using all the different OSs you need to without even having to use anything but your browser. And so from a user perspective, it's kind of what you would expect. You could launch VMs, you could launch other storage, you could create IPs, allocate them around, move them around. So the major pieces are compute, object storage, which is the problem of if you have a bunch of data to store, say petabytes of data, you end up having to go for either a clustered file system approach or a proprietary SAN or NAS or DAS approach. So object storage is stepping back and saying, what if we get rid of the requirements of POSIX, of an actual file system, and say, let's just treat it like HTTP. Let's do a put to upload, a get to download. And then by lessening the requirements of what is required to provide this object storage system, it allowed us to provide better uptime and better sort of flexibility to implement it. And so object storage powers Rackspace Cloud Files, which stores petabytes and petabytes of data and growing every single day. And they open source that project that they had been using for over a year. And it's equivalent to like Amazon S3, if you've heard of that. So then we have all these VMs that you could launch and places you could store things, but we need the ability to provide a catalog for letting users find and discover images and share their own. And so we have a project that does that. I've shown a picture of the dashboard. The last thing is how do you have a centralized authentication to all these things? Nobody chooses a product because of, it has a great login experience, but you don't want to add more and more login components to your infrastructure. So we have a way to tie all of OpenStack together and potentially in with your existing corporate or public authentication system as well. A little more detail. So dashboard, as I said, we showed it. It's powered by Django, and it's really small there, but each of the sort of components are actually little plugins. So this app is actually a collection of lots of different apps. The reason being is that, let's say your company or your deployment needs a specific module, then you could just write a little Django app and drop it directly in there, and it will show up and act as if it was part of the project. So from a user perspective, you could start adding access to internal monitoring and internal metrics and so on and so forth. We're using good new technologies for CSS best practices, such as the Twitter Bootstrap project, which is open source. And through the Launchpad project, we have localization in at least 9 languages, and we're still going through our release process for our next release, which is within a few weeks. And I think we're up to 11 are in progress, and we hope for even more each time. So as far as identity goes, when you log into the system, you have to give your username and password. So what we have is the ability to backend. It's basically an HTTP service that can backend to either a local database of users and passwords and things like that, or it could plug into LDAP, it could plug into PAM, it could plug into AD if you want. So that way you could use your existing user systems. Or you could, if you need this to be in a bubble that's independent of your existing deploys, you can create a new user system in it. It also provides a centralized point for discovering what your cloud is capable of. If you have an arbitrary, this resource of dynamic services, when you add a new component, you want your users to discover it. And so when you authenticate, it actually provides you back a list of here's all the different resources and services that you have access to. And so that way we're building into our cloud basically a foundation to build an entire ecosystem on top of it. So for object storage, again, I said it's got a it runs on it's an HTTP interface, get and put and delete and all those HTTP verbs that your browser and web clients speak. Just talk directly to this. And what it is there are basically you run hundreds of Python processes, and anytime each server is independent of each other, because even with RAID, you still have single points of failure of the server itself, the RAID controller itself, the network coming into the cabinet, so on and so forth. So if you're deploying a whole data center of storage, what you want is so that when you upload, you have basically no single points of failure that are in common, or as minimal as possible. And so using ideas that we've been using in the web world, such as consistent hashing and standalone processes and no databases, no centralized databases, we basically keep 3 copies of everything. And so that we don't lose data, because bit rot on your disks, as the atoms that we use to store our storage get smaller and smaller, the probability of actually losing data goes up just by sitting there. So there's worker processes consistently checking the SHA of every file, and if it's incorrect, not deleting it, but moving it out of the way, so that way when it's found out that we don't have 3 copies, a new copy is moved to that server, and those sectors that were in use are just considered dead forever. And so we don't use RAID at all, because RAID build times of 12 disks with 2 T each, you're talking about a week. So it's just RAID is not a scalable solution anymore. Our image service, again, it's just a way to find and share. By default, you'll probably have various flavors of Linux available. But as a user, you could download them, customize it, upload it, and say, this is my favorite J2EE stack, or this is my favorite Rails stack, and have it pre-configured so you could share and not do as much work, and kind of create best practices within your own enterprises. In the back end, this is not a storage system. It's still wanting to put it on something like the object storage. So by default, we recommend you actually use the object storage to store the images, and this to help with discovery. And then the last thing is, so we have images, we have a way to see what's happening. Let's actually have compute. And so with compute, we basically have workers on each host that when told to launch a VM, it's using underlying open source technologies like KVM or Zen to download images from your object store and determine from the identity system and LDAP that you are who you say you are, and then using things like the Linux bridging system or Open vSwitch in order to connect and pipe your VM into the proper network. And so it's just a Python process that combines all those sort of fundamental parts of a Linux distro nowadays. And the way I like to joke that we're taking web app technologies and web services technologies, and instead of friending or uploading a photo, it's creating a server. But it's the same idea, so it's not rocket science. It's just using underlying APIs of things like libvirt that have been worked on in the in open source for a while. So for clarification, it is not a new hypervisor. We're taking existing hypervisors and building a layer of abstraction on top of them to control them. It's not a block storage system. It's not a new way to store files as far as like POSIX. You could connect to Gluster, you could connect to Ceph, you could use local disks, or if you have a SAN, you can plug into it. So that's a rather large project, and at this point we started out with two basic entities coming together. My team that was an open source contractor and Rackspace. And since then, we've had over 150 people join and more people joining every day. There are people who join and just help out with the open source aspects. There are developers from the Fedora project that work for Red Hat that have been helping us with things like the stabilization and backporting and the stable release. If and when that becomes part of Red Hat is an orthogonal question, an interesting one though. So this was the picture from the very first design summit where we have people from Dell, we have people from Citrix, uh, we have people from Rackspace, of course, and I think there was 40 companies at the first summit where we started working on how do we make this a better platform. And there's basically two different people who want to use a cloud. There's the service providers that everybody thinks of with public clouds, which have tens of thousands of physical servers usually. So they have a massive scale, and they have a certain set of restraints and requirements that are very different than private cloud. A lot of people aren't sure why a private cloud really needs to exist yet. The primary reason for a private cloud isn't to have the same sort of, massive scale that you get in the public cloud, or the the switching capital expenditures to operational expenditures. Because when you have a private cloud, it's still the same problem. You have to buy the servers, you have to set them up, you have to install it. It's more about enablement, and it's about changing the way that your application works, so that you can have the same sort of ability to scale up and down, and to write the code once and run it, whether it's your local sort of data center, or a data center somewhere else, or a data center at a hosting provider. And so that's really why private clouds are really interesting, because in the end, it's just giving you a server, and it's just giving you storage and networking. And so it doesn't change what you're given, it changes how you're given it. And that change is fundamental and important, but it's a little easy to look over it and say that it's not a big transition as far as private cloud goes. So we think OpenStack is important because this eliminates vendor lock-in. We work with all these third-party vendors, but it's a layer on top of it. You could plug in your proprietary storage solution that provides various value, but in the end, you're given a API that will work just as well, at least from a integration point of view, as it would against a naive implementation against local disks or RAID. The other thing is working together, we're going much faster. The project has grown. There's various visualizations using the open source project Gorse, that if you search on YouTube, Gorse OpenStack, you could just see the explosion of growth we're getting from vendors and open source developers everywhere. So we don't think there's one cloud for everybody, but we think there's one cloud platform. So the vision is that you're using the same technology in your data center, hosted privately, in hosted private clouds, or in public sector. So we need this, but we also need it to make it boring. We are talking about servers, and we're talking about networks, and it's things that you need, but if just like the Linux kernel is exciting to certain people, but most people just want it to work so they could build their applications on top of it. They care about the user space. And so similarly, we think OpenStack and infrastructure as a service needs to be like the kernel for your operating system, where it needs to be solid, it needs to be open, it needs to be extensible, so that you could control your sort of kernel for your data center. But it does need to be boring. This is the user space is where the exciting things happen. And that boringness empowers people to build things on top of it because they could count on the stability, and they could count on knowing things are there. And VMs and databases, VMs and storage and networking are just the basics. People are going to want to add the equivalent of these user land apps, such as load balancing as a service and databases as a service, queuing. LinkedIn open source a project called Index Tank that provides search as a service. Wouldn't it be great if when people created those sort of services that you could just as it's easy to install a Linux package, you can install an entire new service in your cloud just by pointing it to another either open or closed source system image and saying run this, and it sort of like spreads out and becomes an entire new service in your cloud, and through the service discovery and so on and so forth. There's definitely a huge fuzzy area, between what is infrastructure as a service and what is platform. Some people consider load balancing to be infrastructure. Some people consider DNS to be part